Hi, I'm Renee Copeland, and today I will be teaching the concept of related rates. The question asks, a rectangle is inscribed in a circle of radius r units. If the length of the rectangle is decreasing at the rate of p units per second, how fast is the area changing when the length is L units? So in this problem, we are trying to find the rate at which the area is changing, which is dA over dt. We are given the derivative of L, which is dL over dt is equal to negative p. Negative because the derivative, the rate at which the length of the rectangle is decreasing, it's decreasing, so it's negative. So basically, first we need to draw the picture of what is going on. So it's a circle, and inside the circle is the rectangle. The rectangle, the length of it is L. And then we're going to call this other side of the rectangle W. The radius of the circle goes to the corner of the rectangle. And then we use the Pythagorean theorem to determine what the length of to r is. We add another radius to find the hypotenuse of W squared plus L squared. So W squared plus L squared is equal to 2r squared. That's our first equation. Next, we're trying to find the rate at which the area changes. So we use the equation area is equal to length times width. So now we want to plug W. We want to find a value for W. So we use the Pythagorean theorem and we solve for W. So W squared is equal to 4r squared minus L squared. W is equal to the square root of 4r squared minus L. So we take this W and plug it into the area formula. So A is equal to length times width, which is 4r squared minus L. Now to find the rate at which the area is changing, we find the derivative of the area. So A prime, or dA dt, is equal to, we have to use the chain rule along with the product rule. So L is the first value times the derivative of the square root of 4r squared minus L, which is 1 over 2 square root of 4r squared minus L. Next, we use the chain rule to find the derivative of the inside of the square root, which becomes 8r minus L. We already know that L is a value, but we know that the derivative of L is negative p. So it's minus negative p. So next, we use the chain rule to find the derivative of L. But since we know that the derivative of L is going to be since we know that the derivative of L is going to be 0, because we already found this derivative, we don't actually have to do that, because we know that this, when we add it, it will be 0. So we don't have to do that part. So we just simplify the equation, and L times 8r plus p all over 2 square root of 4r squared minus L. And that is the rate at which the area of the rectangle is changing inside the circle.